Pulp&Fuel project aims to demonstrate and show how we can produce biofuels on a pulp mill. A pulp mill produces pulp, which is raw material for paper. It consumes large amounts of biomass and it generates side streams, biogenically sourced side streams like black liquor and bark. Biofuels can be separated in different categories. We have first generation biofuels, or essentially food-derived biofuels. Second generation biofuels, which concerns this project, are from non-foodstuff origin. They're also very often called advanced biofuels because they don't intervene with the human food chain. The Pulp&Fuel project aims to demonstrate that we can cost-effectively produce biofuels and especially second generation advanced biofuels on a pulp mill without degrading the economic performance of the pulp mill, and therefore creating jobs.
So the aim of the project is basically to demonstrate that it's possible to produce a biofuel at a sufficiently low cost that you can replace fossil fuels. That's the main aim of the project. And this is very challenging.
What is expected from us is mainly an exercise of design to cost. Because the equipment we have to design have to be able to withstand high pressure and temperatures, so really critical conditions. We are talking about 700 degrees, almost 700 degrees, and 280 bar. We have to propose a viable technical solution, and of course check with the other partners if the solution is viable economically.
We've done major advances on dry gasification, where we've shown that it's possible to push gasification efficiency to relatively high values. So this has been very interesting. Also on the wet gasification, hydrothermal gasification, we've shown that we can gasify black liquor. Black liquor contains a lot of ash. Inorganics that come from cooking chemicals, and we've shown that we can efficiently reuse these cooking chemicals in the pulping process. So it's interesting because we can valorize the organic part and we re-inject the inorganic part in the pulping cycle. On the fuel synthesis part, we've identified ways to efficiently produce biofuels with very high carbon efficiencies from the syngas streams that come from both gasification. So the syngas stream from dry gasification contains a lot of carbon monoxide and some hydrogen. The syngas stream from wet gasification, hydrothermal gasification, contains a lot of hydrogen. And we've shown that these two streams can be very efficiently valorized in Fischer-Tropsch, and they show that there's actually a synergy between the two processes, the gasification process.
This project is important since it can contribute to the reduction of greenhouse gases in the transport sector. And we need to look everywhere for resources that can be used to solve this big problem for the society. And the waste resources or residuals from the pulp mills is one part of it. It cannot solve everything, but it could be one part of the solution.
The main result of this project is, of course, an engineering design for a demonstration plant. So ideally we would like to, of course, in a future project build this plant and to show that we can actually produce biofuels on a pulp mill. And then after this demonstration phase, of course, we need to go for an industrial deployment of the technology.